Here we're going to look at a word problem, a problem that focuses on rate. So Ada always bikes at 16 miles per hour. The long way home from school took 15 minutes longer. Her odometer claims the total round trip was 28 miles. How many miles shorter is the short way? Okay, so one thing that we can keep in mind is that her rate is in miles per hour. So if we don't remember the formula, we can look back at the pieces and know miles per hour, miles divided by hour, equals rate. So miles, that's a distance. Hour, that's a time. So rate equals distance divided by time. Or if I multiply both sides by time, another way to say that is that rate times time equals distance. Now I have the short trip, the long trip, and then the total trip. And I want to, some things that we can fill in pretty straightforwardly are the rate is always 16 miles per hour. We know that the total trip was 28 miles. Now the time we don't know, but we know that the long way took 15 minutes longer. Okay, so 15 minutes in our frame here, because we're dealing with miles per hour, 15 minutes is a quarter, so we have to add a quarter to the time. So if I don't know what the time is, I do know the relationship between the time. And in the same way, I don't know the distance, but I do have a relationship between the distances, that when I add those two distances together, it gives me 28. Or another way to say that is, if I take one distance and subtract that from 28, I should get the other distance. I have to get the other distance. Okay, so now we can develop a couple equations because we know that rate times time equals distance. So if I have my rate times time equals distance, and then here I have my rate times my time equals my distance. Okay, that's an equal sign. So now I have two equations with two variables. I can do a substitution. Now there are a couple ways to approach this. One is we can say, well, I already know d is equal to something else. I could substitute that in. That's absolutely fine, and you could. In this case, I'm going to do something slightly different because my question asks how many miles shorter. So I want my final equation that I'm working with to have my distance in it. So in order to do that, I want to substitute out this time. So I'm going to rewrite solved for time. So if I divide by 16 on both sides, I find out time is equal to the distance divided by 16. Okay. So now I can take my t from this equation and substitute it in for something equivalent, d over 16. So now I have 16 equals d over 16 plus 1/4. That quantity equals 28 minus d. So now I have everything in terms of d. So I'm going to simplify this. I'm going to distribute my 16. So 16 sixteenths is 1. 1 times d gives me d. 16 times 1/4 gives me 4. 16 fourths, which is 4. And then I have 28 minus d. I'm going to move the d's to both sides by adding a d on both sides. So I'm going to add a d on both sides, but I'm also going to subtract a 4 from both sides. So I'm going to add a d and subtract a 4. So now that I've done that, I have d plus d, that's 2d. And I have negative 4 plus 4, so I have 0. And then I have negative d and positive d, so that's 0, and I have 28 minus 4, so 24. Alright, and then of course I'm going to divide by 2, and I get d is equal to 12, and remember our distance was in miles, so I have 12 miles. But now I have not yet answered the question. Remember the question says, how many miles shorter is the short way? So this is how long the short way is, right? So I could say that is equal to 12. So my long way is 28 minus 12. So that's 16. So to answer the question, how many miles shorter is the short way? Well, that's 16 minus 12. So it's 4 miles shorter. All right, so that should give us a good idea of how to work through those problems. You can work through these in different ways. We could have plugged in an equivalence for t, figured out what t was, and then used our original equation to solve for d after that. And that'd be fine too.